Hey everybody, welcome to lesson 317. So what I've decided to do, and if this is not the 2020-21 school year, please just ignore this, but what I've decided to do this year is I've decided to flip the lesson for those of you who are at home. So what I'm going to want you to do, go into Desmos and complete the lesson, but if you're struggling with some of the questions, what you can do is you can watch this video and hopefully this video will help you through the Desmos. If not, you can always check GoGuardian and we can see if you can type in a message. And again, please remember, I'm watching all my in-person students, the students who are at school. So if I'm helping someone, I may not get to your message right away. It may be 5-10 minutes later. So don't think that I'm just sitting at my desk waiting for you to message me, because I'm also working with the kids at school as well. And if push comes to shove, we can always set up a Google Meet where I can go through the lesson with you personally. So let's get started here. So problem 61 is the first one you're going to have. And this may look a little bit different if you're in Desmos. So for example, if I open up Desmos, here it is, and I go back, here's the student preview. Let me go back to the first one. The very first slide is just, a warm up for you. So I'm not going to give you a math warm up. Here's a thinking warm up to get your mind working. In this chapter, you have used rules to find y values to go with x values in a table. Then you graph the x-y pairs you found. Today, what we're going to do is we're going to examine how rules, tables, and graphs can be used to represent new situations. So that's going to be our goal. So we're going to look at how we can learn what we've done in the past, and we can hopefully try and avoid some common graphing errors. So when you look at problem 61, here it is. Now, this is only A. If you click on the next slide, then there's B, then there's a C. So I just want you to keep that in mind. So when you're looking here, A and B is on this page. The next slide has C, D, E, and F. So don't look at what I'm talking about and think, how can I do this? It doesn't look the same. What's the same is just I divided it up more on Desmos. So Miss K's class is studying the dented square, shape shown at the right. This shape is formed by removing a square with the side length 1 from a larger square. Her students decide to let x represent the side length of the large square and y represent the perimeter of the entire shape. So again, if you haven't attempted this yet, go ahead, give it a try in Desmos. Only come back to the video if you are having questions, if you don't quite know what's going on, or if you're done and you want to check your work. So what is the rule? That is, what rule could help you find a perimeter for any value of x? Now notice first it says find a perimeter. So if I take a pen, let's go with red for a color. We know that because this is a square. Why? How do we know it's a square? Because it says it's a square right here. So we know that this side is going to be x because that side's x. We know that this side is going to be x. Now this side right here is x, but notice something's missing right here. And right here it says that's a 1. So we know this is going to be x minus 1. Then this will be a 1. This will be a 1 as well. So if I had to find a perimeter of this, I just count up the x's. And if we remember, we did this in our last unit. So I'm going to have 4x. Now I count up my 1's, 1, 2, 3, but it's minus 1. So what's 3 minus 1? 2. So this is my perimeter. And it says, find a perimeter of the dented square. That is, what rule could help you find a perimeter for any value of x? So I'm just going to put that y equals in front of it. So that is the rule that I'm going to be looking for. So that's what it's looking for in A. Now it says make a table for the rule you found. Make sure the x values you are going to use are appropriate for this situation. What are the possible x values? So here we got to think about it a little bit. If this is going to be the area of a square, can you have negative numbers? No, you can't. How do you have a square that's a negative 1 for a side length? Is it going to implode? I can't even, think about that. So we don't have to have any negative numbers. Can we have a 0? No, because if this was 0, how do you get a square if the side length is 0? Now, here's the trickier part. Can you have a 1? Well, if this is 1, how can this side be 1? So we really can't have a 1. It's got to be greater than 1. So I'm going to just start with a 2. And I'm going to write a 3 here. And I'm going to write a 4. Now, some of you might be looking at this and saying, but Mr. Wittun, if this is a 1, wouldn't that be a 1 and that be a 1? So wouldn't it be like 4 to 5? Well, all we know for sure is that x has got to be greater than 1. So instead of trying to guess and trying to figure out what it would be or getting a ruler and measuring, we're just going to say it's 2 or higher. We know it's got to be greater than 1. So I'm going to do this. I'm just going to go 2, 3, 4, 5, 6, 7, and 8. So we've done this a lot in the past. So let's look at the rule. 4 times x plus 2. So if I plug 2 in for x, what's 4 times 2? 8 plus 2 is 10. Which means if x was 2 units long, the perimeter, remember, we're it's a dented square, so going in here would be 10 units. Let's try the next one. 4 times 3 is 12. 12 plus 2 is 14. Now, you might start to see a pattern here. What's 4 times 4? So 4 is x. 4 times x, or 4 times 4 is 16, plus 2 is 18. Now, do you see the pattern? And we can keep going through these, but do you see how it's going up by 4 each time? And we've talked about this in class quite a bit. As it keeps going up, this is where you find that number 4. So this is where, once we start to understand what we're looking at here as far as this rule, we know that it's going to go up by 4. So what's 18 plus 4? Well, 18 plus 2 is 20, so it must be 22. And we can check our work. 4 times 5 is 20, plus 2 is 22. So then plus 4 more is going to be what? 24? 25? No, 26. I almost wrote 24 there. And then 4 more is going to be 30. And we can check our work. 7 times 4 is 28, plus 2 is 30. 4 times 8 is 32, plus 2 is 34. Plus, we can look that each one goes up by 4. So now that we've done that, let's move on. It says C, in this situation, x has a lower boundary value. This means that it must be greater than a specific value for the situation to make sense. Using what you know about writing inequalities, write an inequality statement for this limitation. So we talked about what x can be. We know it can't be a negative. And all we know for sure is it can't be a 1, so it's got to be greater than 1. So if I was going to write this, it would simply look like this. X has got to be greater than 1. Do we know? And again, you might look at it and say, it's probably not going to be 2, but we don't know for sure because not everything's drawn to scale. All we know for sure is x has got to be greater than 1. So D, if you were to graph the inequality in part C on a number line, it would have an open circle, Y. So again, if we drew it on a number line, it would look like this. With the number, and the number line would be underneath. It would be an open circle. And the reason for this is because it does not include 1. It's got to be greater than 1. And that's all we know for sure. If this was filled in, it would mean it could be 1 or anything greater than 1. But we know it can't be 1. So that's why we would draw it with an open circle. Now, do you think the points in your graph should be connected? Justify your answer for that. So when we look at it, yeah, it should be connected because the shape and thus the perimeter also exists for values of x between integers. So what that basically means, if we look at this, we could have a side length of being 1.5, 1.75, 3.5, 5.5. So we would connect all these points on a graph to represent that. So the last thing it wants us to do is use what you decided in part D and E, make a graph for your XY table. So if I come here, I've got a table set up. I'm only using this first quadrant because I don't have negatives. So I can count these off 1, 2, 3, 4, 5. So here's my 5th line. And I'll maybe make a little tick mark there. So then 1, 2, 3, 4, 5. So here's my 10. And I'm going to stop there. So look here, it's 1, 2, 3, 4, 5. Make a mark there. 6, 7, 8, 9, 10. And I'm going to go up higher than this. 10, 11, 12, 13, 14, 15. And I guess I did not look back. Oh, I made a mistake. I didn't look back, and I should have looked at this and say, holy moly, this goes up to 34. So maybe what I'll do is erase this, because it won't go all the way up to 34. And maybe what I'll do is I'll go 2, 4, 6, 8. So this is 10. I'm going to go up by 2's here. 2, 4, 6, 8, 10. So this is my 20. And then 2, 4, 6, 8, 10. So this would be my 30. So what's my first number? If I look back at it, it's 2 and 10. So here's the tricky part. So my first is going to be 2. And then it's going to be, the coordinates, the x is going to be 2 and 1. Can it be 1? Let's look at that. Could it be 1? Okay, we wrote the inequality here. We know it's got to be greater than 1. So we can actually graph that. And we would graph that. What would 1 be? 1 times 4 is 4 plus 2 is 6. So 2, 4, 6. I could put it here, but what I'm going to do is I'm going to keep it as an open circle. Now, if I go back here, I know 2 is going to be 10. Oop, I wrote this in the wrong one, didn't I? Did anybody else catch that mistake? You did? Good job. So when I look at it again, it's going to be 6, but here's my 1. So my 2 is going to be 10. My 3 is going to be 14. My 4 is going to be what? 18. And we can go back and double check. You can look back here if you need to. But my 4 is going to be 18. And then it's going to go up to 22 for 5. And then 6 is going to go up to 26. Notice how I'm just going up 2 over 1, up 2 over 1. I'm actually going up 4 because each one of those lines is 2. So this is where I'm going to cheat a little bit because I've got these nice lines. So what I'm going to do is I'm going to start my line there, and I'm going to have it up, and my arrow is going to be pointing upward. So how did you graph it? Did you graph it like this? All right, so that does complete problem 61. So I'm going to create a new video, but if you do have questions about 61, I'm going to create a new video for problem 62. Make sure you watch the video if you need help.